Good day. We'll discuss correlation analysis, specifically on the comparison of the two formulas, these two formulas. So our book uses this formula and other books use this formula. So let's try to solve some problems and compare the answers. Of course, if your previous school uses either of these two, then of course if they have the same answer, then you can use your previous formula. So we have this summary of the correlation coefficient and strength of relationships. If you search on the Google, you can find other summary also. So for us, we will be using this summary. Now remember, correlation measures the association or the strength of the relationship between two variables. So let's compare this. We'll get two examples from the book. So on page 146 we have this. It's a comparison between the math score and the English score. So first we'll be using this formula from the book. So we'll be needing the mean, x mean, the mean of the x's or the math score, the mean of the English scores. We'll be also needing their differences of this, and the squares of these two differences. So that's why we have this table. Okay, so this is originally the given. Okay, so these three columns. So first we'll find the x minus the mean. So solving for the mean, we'll just have for the x 48 divided by 10 because there are 10 students, so we have 4.8. And then we have this negative 0.8 here is for the x minus 4.8. So this is 4 minus 4.8 is negative 0.8. Next we have 5 minus 4.8, we have 0.2. 9 minus 4.8, we have 4.2, and so on. Similarly, we'll get the mean of the y or the English score. So we have the total is 50 divided by 10 is equal to 5. And again, we'll do the same thing with the x. So for y, we have 5 minus the mean 5 is 0. 4 minus 5 is negative 1. 8 minus 5 is 3. 3 minus 5 is negative 2. And so on. After this, we'll get the squares of these two. So just square the values. So since these are squares, so obviously all the answers here are positive. So this is negative 0.8 squared, we have 0.64. 0.2 squared is 0.04. 4.2 squared is 17.64, and so on. For this column, we have 0 squared is 0, negative 1 squared is positive 1, 3 squared is 9, negative 2 squared is 4, and so on. And last, we'll get the product of these two. Okay, so this is now the result for the last column. So negative 0.8 times 0 is 0. 0.2 times negative 1 is negative 0.2. 4.2 times 3 is 12.6. Negative 2.8 times negative 2 is 5.6, and so on. And at the bottom, you'll just take the sum of these three columns. Take the sum, you add. Okay, after which, we will be substituting now the values. So what is this value? This is the sum of the product of the differences. So meaning this one, and the product is at the bottom, which is 58. That is why we have 58 here. And then we have the square root of the square of the difference of x. So we have this 65.6 times, so y we have 60. Using your calculator, you will get 0.92. So this means we have a strong positive correlation. Okay, that is based here. 0.92 is here, so we have strong correlation. And since it's positive, so strong positive correlation. So going back, that is a high score in math is highly associated with a high score in English. Now let's use the other formula. So this one. So in this case, we will be only needing the sums, which is at the bottom, and the x squared, y squared, and xy. So x squared, meaning you'll just take the square of this column. So 4 squared is 16, 5 squared is 25, 9 squared is 81, 2 squared is 4, and so on. For the y squared, you will square this column. So 5 squared is 25, 4 squared is 16, 8 squared is 64, 3 squared is 9, and so on. And for the last, we have xy, so just multiply these two columns. 4 times 5 is 20, 5 times 4 is 20, 9 times 8 and 7 is 72, and so on. And at the bottom, you just take the sum of each column. Okay, so these are the sums. And now we're ready to substitute. So n is 10 because there are 10 students. Summation of xy, so here we have 298 minus the product of these two sums. Summation of x is 48, summation of y is 50. And on the denominator, we have square root of this first group. We have n is 10. Summation of x squared is 296. Then this one, the square of the summation. So this is the summation. So the square of this, so 48 square. And then on the other group, we have n is 10 again. Summation of y squared is 310. Minus the square of the summation, which is 50. So using your calculator, you will arrive with the same answer, which is 0.92. So either case, either formula will give us the same result. So if in your previous school you're using this, then of course you may use this. Or if you're using this in your previous school and you're comfortable in using this, then of course you can also use this. In the end, we'll have the same answer. Another example, again, math and English score, but with different set of data. So let's go back again to our first formula, which is the formula on the book. We have this. So x minus, first we'll be needing the means, two means. So the mean of the x's is 4.9 because it's 49 divided by 10. And the mean of the y's is 55 divided by 10, which is 5.5. And then find this for the x minus the mean of the x's. So we have 9 minus 4.9, which is 4.1. 3 minus 4.9, we have negative 1.9. 4 minus 4.9, we have negative 0.9, and so on. Next, for the y, we have 3 minus 5.5, we have negative 2.5. 6 minus 5.5, we have 0.5. 7 minus 5.5, we have 1.5, and so on. On the next column, you just square this. So 4.1 squared, we have this. Negative 1.9 squared is 3.61. Negative 0.9 squared is 0.81, and so on. Next, for the square of this, we have this. So negative 2.5 squared is 6.25. 0.5 squared is 0.25. 1.5 squared is 2.25. So completing this column, we have this. And last is to multiply these two columns. 4.1 times negative 2.8, we have negative 2.5. Negative 1.9 times 0.5, we have negative 0.95, and so on. Okay, so now we're ready to substitute these values. So the numerator is actually the last column, the sum of the last column, which is negative 71.5. So look at this. And on the denominator, we have the square root of this, which is, on the square, we have 84.9. And for the y, we have 76.5, giving us a negative 0.89. So meaning negatively correlated. So this means that we have a strong negative correlation. So if you have a high score in math, then you will have a low score in English because they are negatively correlated. Previous examples, it's positively correlated. So it means that when you have a high score in math, then of course you have a high score in English. But this one is the opposite. So again, you may use either of these two formulas. So we have this formula, another formula. So we'll be needing x squared, y squared, and xy. So for the x squared, you just square this column. 9 squared is 81, 3 squared is 9, 4 squared is 16, 7 squared is 49, and so on. Next, for this column, take the y squared, or the square of this y column. We have 3 squared is 9, 6 squared is 36, 7 squared is 49, 4 squared is 16, and so on. And last, multiply these two columns. 9 times 3, 27. 3 times 6, 18. 4 times 7, 28, and so on. And lastly, get the sum of each column. After getting the sum, you're now ready to do the substitution. N is 10. Summation of xy, which is 198, minus the product of the summation of x and summation of y. So we have 49 times 55 divided by the square root of this first group. We have n is 10. Summation of x squared is 325 minus the square of the summation. So we have 49 squared. Then on this next group, we have n is 10. Summation of y squared is 379 minus the square of the summation of y, which is 55. So using your calculator, again, you will arrive with negative 0.89. So again, they have the same value. So you may use either of these two formulas. Now let's go to regression analysis. So if you want to predict a value, after you get the relationship between the two, this regression equation line or regression line equation will help you predict the value of your y given a value of your x. So it's an equation of a regression line given by y equals mx plus b. So I also have another video for this one, but of course the format or the form of the regression line uses different variables. You may also watch that video, or you may continue using this formula, y equals mx plus b. This is actually the slope-intercept form. If you can still remember your basic mathematics on equation of the line. So in this case, m is the slope and b is the y-intercept. Now the formula for the slope is this, and the formula for the y-intercept is this one, where n is the number of data pairs. Now our rule for both m and b is up to 3 decimal places. Others use 2 decimal places, but still the answers are almost the same. So given the data below, find the equation of the regression line and provide an interpretation of the result. So this example is from your book. So we're only given with this data. So all we need to do is to get the summation of x, summation of y, the xy and its summation, the x squared, and the summation of x squared. After that, we will compute the mean of the y and the mean of the x bar for the y-intercept. Okay, so let's start. So let's start first with xy. So xy is 4 times 5, which is 20. 5 times 4 is 20. 9 times 8 is 72. 2 times 3 is 6. Take note, it's x, y. Now on the last column, it says x squared. So meaning the x should be squared. Take note of your labeling. So the x squared should be, the x should be squared. So 4 squared is 16. 5 squared is 25. 9 squared is 81. 2 squared is 4. And so on. Then you get the sum of each column. So we have this summary of the values. Our n is 10 and the different summation. These are from the table. Using the formula, we have this, and substituting these values, we have n is 10, summation of xy is 298, minus summation of x is 48, summation of y is 50, and on the denominator we have n is 10, summation of x squared is 296, minus the square of the summation, which is 48 squared. Okay, using your calculator, you will get 0.884. So take note, the slope is positive, so it is, or it implies that the correlation also is positive, meaning the line is like that, to the right. Okay, because the slope is positive. Now, computing for the y-intercept, we have this. We need the mean of the y, which is 50, divided by 10, which is 5. And the mean of the x's, we have 48 divided by 10, which is 4.8. Okay, using your calculator and the formula, you will get 0.757. So therefore, the line of best fit, or the linear regression line, or the regression line, is equal to, or y is equal to 0.884x plus 0.757. So interpretation. So marginal change is the magnitude of the change in one variable when the other variable changes exactly 1 unit. So the other variable is x, of course. So the marginal change now in this problem is the 0.884. Whenever you change x by a unit, the whole y will change. The value of y will change. Okay, so this means that for every change in the value of x, which is the math score, the value of y, which is the English score, also changes at 0.884 unit on the average, because it is our marginal change. So the value of y-intercept, which is b, which is 0.757, means that if the student, if the score of the student in math, what is this? These two, math score and English score, if the score of the student in math is 0, then of course his English score is 1. So this means the English score of the student would be 1 if his score in, so this is wrong, if his score in mathematics is 0. Okay, if he scored 0. Okay, because if this is 0, we only have 0.757. So he can score 1 point in, or a point in English. So take note, it helps us in predicting the value of the other variable. So say for example, if the student's score in math is 3, what will be his English score? Okay, we can now use the regression line equation. So substitution, so we have this, and then we have 3.41, so he can score a 3 point. Number 2, if the student score is 9, then of course using again this one, his score in English will be 9. Okay, so again, this regression line will help us predict the value of the other variable. So we have another equation, or another problem. So we have the number of study hours and the final grade in math. So obviously, in reality, if, or mostly, if we study more, then of course will expect more. Okay, so the higher the study hours, then of course the higher your expectation of your grade will be. So this is actually, by just looking at the data, we are sure that they are positively correlated, or again the slope will be positive. So let's try. So we have this formula. We will be needing x, y, and x squared. So we have this. So xy, we have 2 times 78, we have 158. 3 times 83, we have 249. 5 times 85, we have 425, and so on. Then for the x squared, take note only the x, square the x. So 2 squared is 4, 3 squared is 9, 5 squared is 25, and so on. And then last, get the sum of each column. So you have this, and then you substitute these values from the formula or on the formula. Okay, so we have n now is 6, summation of xy is 3998, summation of x is 45, summation of y is 517, divided by n is 6, summation of x squared is 465, minus summation of x is 45, and then take the square. And we will arrive with 0.945. So the slope is positive, or it implies that it is positively correlated. The two variables are positively correlated. For the y-intercept, we have this formula, so we'll be needing the mean of the y. So 517 divided by 6, because there are 6 pairs, and 45 divided by 6 for the mean of the x's. Substitute these values on the formula of the y-intercept, we have 79.083. So hence, we have this equation of the regression line. 0.945x plus 79.083. So in the problem, the value of m, which is 0.945, is the marginal change, meaning for every change in x, which is the number of study hours, the value of y, which is the grade, changes by 0.945. Okay, so if the student studied for 10 hours, what will be his predicted math score or math grade? So using this regression line equation, substitute n x as 10, so his possible grade is 89. Now if the student only studied for 1 hour, so his predicted grade is only 80. Okay, so the more you study, of course, the more you will expect a higher grade. And last example, we have the number of days absent and of course your score in a 50-point math quiz. Obviously, when you're absent, the more you absent, the more you will get a low score. So obviously, by just looking at this, we'll have a negative correlation, because the higher the absences, the lower your score. So let's try to find this out by looking at the slope also. So again, we have this. So xy, 1 times 47 is 47, 2 times 40 is 80, 3 times 35 is 105, and so on. And on the last column, you just take the square. Okay, so x squared, we have 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And then on the last row, just take the sum of each column. Okay, and then we have this. N is 5. The summation of xy is 415. The summation of x is 15. Summation of y is 164. Divided by n is 5. Summation of x squared is 55. Minus the square of the summation of x, which is 15. Using your calculator, we have negative 7.7. So it's a negative slope, so it's like that. So negative correlation. Then for the intercept, the mean of the x's, 15 divided by 5, which is 3. The mean of y's, we have 164 divided by 5, which is 32.8. And then using these values, we will get the b or the y-intercept is equal to 55.9, giving us this linear equation or regression equation. So for every change in the value of x, which is the number of absences, the value of y, which is the grade also, or the score, also changes by negative 7.7 unit on the average. This means that as your number of absences increases, your score decreases. So that's why it's negative, or they are negatively correlated. So if the student has no absences, then we can say that he can surely perfect the quiz. So last, if the student has 3 absences, what will be his math score? So using the regression line equation, substituting the value of x, which is 3, so his possible math score is 33. Now, if the student is only absent once, what will be his math score? Using again the formula or the regression line equation, his predicted math score is 49. Okay, so again, if of course he cannot, or he's not absent, he's always present, then obviously he has a greater chance of perfecting the quiz. Okay, so there are 2 or more formulas that are being used by other books or references. So you may do so, use the formulas which for you is comfortable, as long as, of course, at the end we'll have the same answer. Okay, thank you for listening.